So today we are starting a new subject, that is vector analysis, and previously we have discussed 3D analytical geometry, calculus and real analysis. So today we'll be starting with vector analysis, and in today's video we'll see questions related to basic vector algebra that were asked in both CSE and IFoS examination. Let's see them one by one. So there were only 4 questions asked related to this topic. One is in CSE, that's asked in 2016, and 3 other questions were asked in forest service examination. So let's see all the questions one by one. Now the question 1 is, prove that the vectors, that is A vector, B vector and C vector, can form sides of a triangle. So we are supposed to show that if A vector is 3i cap plus j cap minus 2k cap and B vector is minus I cap plus 3j cap plus 4k cap and C vector is 4i cap minus 2j cap minus 6k cap, then we are supposed to show that these 3 vectors can form side of a triangle. That is, using these 3 vectors we can form a triangle. So the easiest way to show that these 3 vectors form sides of a triangle is to check if these vectors satisfy basically the triangle law. If these vectors satisfy triangle law. And what is triangle law? So triangle law basically states that sum of any 2 sides is equal to the third side. So it says that sum of basically 2 sides is equal to third side. So if we check a vector B vector plus C vector, so it will be equals to minus I cap plus 3j cap plus 4k cap plus C vector, that is 4i cap minus 2j cap minus 6k cap. Now if we add in these 2 vectors, we'll get 3i cap plus j cap minus 2k cap, which is basically A vector. So from here you can see that B vector plus C vector is equals to A vector. So this basically these 3 sides satisfies the triangle law. So from here we can say that basically A vector, B vector and C vector can form sides of a triangle. That completes the first part of the question. Now the second part is, find the lengths of the medians of the triangle. So we are supposed to find the length of medians of triangle. So for example, if let's say A, B and C is our triangle, and let's say midpoint of AB is F, midpoint of BC is G and midpoint of AC is H, then the median will be basically AG, BH and CF are basically 3 medians of triangle ABC. So if ABC is triangle and F, G and H are midpoints of sides AB, BC and CA respectively, then median of triangle ABC will be basically AG, BH and CF. So we are supposed to find length of AG, BH and CF. Now first let us find out the midpoint. So if my point A that I'll get using vector A will be 3, 1 and minus 2. My point A will be 3, 1 and minus 2. Likewise my point B will be minus 1, 3, 4 and point C will be 4, minus 2, minus 6. So first let us find out the midpoint. So midpoint of AB will be that is f will be equals to 3 minus 1 divided by 2, 1 plus 3 divided by 2, and minus 2 plus 4 divided by 2, which is equals to 1 comma 2 comma 1. So our point f is 1 comma 2 comma 1. Likewise, midpoint of BC, that is G, will be equals to minus 1 plus 4 divided by 2, 3 minus 2 divided by 2, and 4 minus 6 divided by 2, which is equals to 4 minus 1 3 by 2, 3 minus 2 1 by 2, and 4 minus 6, that is minus 2 by 2, which is minus 1 only. So this is our point G, and likewise midpoint of CA will be H, that will be equals to 3 plus 4 divided by 2, 1 minus 2 divided by 2, and minus 2 minus 6 divided by 2, which will be equals to 4 3 7 by 2 minus 1 by 2 and minus 8 by 2, that is minus of 4. So these are the midpoints of the sides of triangle AB, BC and CA. Now we are supposed to find the lengths of the median. So length of median AG will be equals to, my point A is 3 1 minus 2, and point G is 3 by 2 1 by 2 and minus 1. So length of side AG will be equals to 3 minus 3 by 2 square plus 1 minus 1 by 2 square plus minus 2 plus 1 square, that I just calculated using distance formula. That says that if A, B, C and E, F, G are 2 points, let's say, in R cube, then the length AB will be equals to A minus E square plus B minus F square plus C minus G square. Using that formula, I calculated length AG, that will be equals to 3 minus 3 by 2 is 3 by 2 square plus 1 minus 1 by 2 is 1 by 2 square plus 1 minus 1 square. So that will be equals to square root of 9 by 4 plus 1 by 4 plus 1. That is square root of 14 by 4. That means square root 7 by 2 units is length of median AG. Likewise, we can calculate length of median BH. Length of median BH will be equals to, so my point B was minus 1 3 4, and my point H was 7 by 2 minus 1 by 2 and minus of 4. So length of BH will be minus 1 minus 7 by 2 square plus 3 plus 1 by 2 square plus 4 plus 4 square. That will be equals to square root of 9 by 2 square plus 7 by 2 square plus 8 square, which will be equals to square root of 81 by 4 plus 49 by 4 plus 64, which is equals to square root of 130 plus 64 times 4 by 4, which is equals to square root of 386 by 4. That is square root of 193 by 2 units. Likewise, we can calculate length of CF median. So my point C was 4, minus 2, minus 6. Likewise, my point F was 1, 2, 1. So this length will be equals to square root of 4 minus 1 square plus minus 2 square plus minus 6 minus 1 square. which will be equals to square root of 4 minus 1 is 3 square plus minus 2, that is minus 4 square plus minus 7 square, which is equals to square root of 9 plus 16 plus 49, that is 49 plus 25. Square root of 49 plus 25, which is square root of 74 units. Now that is the length of all the medians, and that's all we were supposed to calculate for this question. So this completes our question number 1. Now let's move on to see the question second. So the question second is, prove that if A, B, C, A bar, B bar and C bar are vectors. So our claim is, if this relation satisfies, so the claim is basically this relation satisfies if and only if either our B vector is 0 or C vector is collinear with A vector or B vector is perpendicular to both A vector and C vector. Now let's see how we can prove this. Now let's start with the forward part first. Let us assume that the given relation holds, that is A vector cross multiplied by B vector cross C vector is same as. So if this is equals to this term, then the expansion of A vector cross B vector cross, like we'll write its expansion. So that is A dot C, that is dot product of A with C times B vector minus dot product of A vector with B vector times the C vector. And likewise, if I expand the term on right hand side, so it will be equals to dot product of A vector with C vector times B vector minus dot product of B vector with C vector times A vector. Now if you see that this term is equals to this, so we can easily balance out these two terms. So we'll be left with minus of A vector dot B vector times C vector is equals to minus of B vector dot C vector times A vector. And if I simplify it, it will be equals to B vector dot C vector times A vector minus A vector dot B vector times C vector, which is equals to 0. And now this thing can be written as B vector cross multiplication with A vector cross C vector. And if this is equals to 0, then like this term will be basically equals to 0 if you observe that this term will be equals to 0 if the following condition satisfies. If any of the following condition satisfies, that is if I take my B vector as 0 vector, our second condition can be if C vector is collinear with A vector. That is C vector is equals to some lambda times A vector. Then from here we'll get that C vector cross multiplication with A vector is 0. Or third condition can be B vector is perpendicular to both A vector and C vector. That can be verified from here as well, that is both these terms are individually 0, and that happens when B is perpendicular to C vector, likewise when B is perpendicular to A vector. So that if any of these three conditions satisfy, then the relation, that is relation star, holds. Now if we look at the converse part, in this we'll assume that each of the conditions satisfies individually, and for the given condition we'll show that the above relation holds. So first let us assume that. So first condition is, first if my B vector is 0 vector, then if my B vector is 0 vector, then A cross B vector cross C vector is equals to 0, and also my that is A cross B vector cross C vector is also equals to 0, because I have assumed my B vector is 0. Then in that case we can say that this relation holds. Likewise, if I assume second condition, that is if my C vector is collinear with A vector, in that case I'll assume that C vector is some lambda times A vector, and if that's the case, then if I compute this will be equals to A vector times B vector times lambda A vector, and if I expand it, it will be equals to A vector dot lambda A vector times B vector minus A vector dot B vector times lambda A vector, and this simplifies to lambda times A square B minus A dot B A, and there's lambda as well. Now, or we can just pull out lambda from the entire equation. So this is what we got, but if I expand this, that is the term on right hand side, so it will be equals to A vector cross B vector cross lambda A vector, and again it simplifies to A vector dot lambda A vector times B vector minus B vector dot lambda A vector dot A vector, and it simplifies to lambda A square times B minus B dot A times A, and there is lambda as well that I pulled out, and this term can be written as lambda A square B minus A dot B A, and I am able to write this because A dot B is same as B dot A. So from here I'll get that lambda, if you observe that this is basically equals to A vector cross B vector cross C vector. So from, if this condition holds, that is C is collinear with A, then also the given relation holds. Now let's see if third condition holds, then the given relation holds or not. So the third condition is B vector is perpendicular to both A vector and C vector, that is B dot A is equals to 0 and B dot C is again equals to 0. Now if I compute this term, then it will be equals to A dot C times B minus A dot B times C, and since A is perpendicular to B, so from here this term will be equals to 0, so we'll be left with A dot C times B. Likewise, if I compute A vector cross B vector cross C vector, so it will be equals to A dot C times B minus B dot C times A. Again this term is equals to 0 using this, so it will be equals to A dot C times B. Now if you observe that this term and this term is equal, so from here we can say that A cross B cross C is same as A cross B cross C. So we have verified that if any of these three conditions satisfies, then the given relation holds, and if the given relation holds, then any of these, like at least one of these conditions satisfies. So this completes our second question. Let's move on to discuss the third question that was asked in 2014 for a service examination. So the question is, for three vectors show that this relation holds. So we are supposed to show that this is equals to 0. So for that, what we'll do is we'll expand each of these terms individually and see if any of the terms balances each other or not. So a vector cross b vector cross c vector plus b vector cross c vector cross a vector plus c vector cross a vector cross b vector equals to 0. That's what we were supposed to prove. So this will be equals to, if I expand this term, so it will be equals to a vector dot c vector times b vector minus a vector dot b vector times c vector plus b vector dot a vector times c vector minus b vector dot c vector times a vector plus c vector dot b vector times a vector minus c vector dot a vector times b vector. Now if you see that this term basically balances this one because a vector dot product of AB is commutative, is same as this. Likewise, this vector balances this one and this vector balances this one. So the entire term becomes 0, and that's what we were supposed to show in this question. Or if you don't want to approach it by this method, like if you don't remember how to expand this term, then what you can do is you can assume a vector as a1 I cap plus b a2 j cap plus a3 k cap. Likewise, you can assume b vector as b1 I cap plus b2 j cap plus b3 k cap, and likewise c vector as c1 I cap plus c2 j cap plus c3 k cap, and evaluate each of these terms individually. But then it will become too lengthy to solve it via that method, so it's better to remember some basic results in vector analysis. Now let's move on to discuss the last question that was asked on this topic. So the next question says that prove that the shortest distance between a diagonal of a rectangular parallelepiped whose sides are A, B and C and the edges not meeting it are this. So we are supposed to show that if there is a diagonal, then the shortest distance between that diagonal and the sides that are not touching that diagonal in any way are these three. So if we observe that, we can take this diagonal, that is O, and let's name this point as, let's say, D. And let me name other points as well. Let's name it as A, B, C, D, E, F, G. Yeah, so if you see that the main diagonal that this parallelepiped has, OD, that is OD is our main diagonal. Now any side that is not touching the diagonal OD can be either BE, BE, one can be AE, and other can be this AG. So these are the only sides that are not touching diagonal OD, and there are other sides as well like CF, but the CF, if you see that CF is basically parallel to AE only. So these are the three lines that are basically not touching the main diagonal. Now if we calculate direction cosines of OD, then it will be basically A, B and C, or you can write it as A I cap, B J cap and C K cap. Likewise, direction cosine of, let's say, AE would be 0, B, 0. Now we are supposed to show that like shortest distance between OD and AE will be, so shortest distance between OD and AE will be equals to, so we'll use shortest distance formula. Now the shortest distance formula says that if let's say these are the direction cosines, and let basically x1, x2, x3 and y1, y2, y3 are basically the points via which these lines are passing. So shortest distance formula says that x1 minus y1 comma x2 minus y2 and x3 minus y3, and the direction cosines, that is a, b, c and 0, b, 0, divided by the cross product of basically the direction cosines, that is a comma b comma c cross product 0 comma b comma 0, their square root. So this is the shortest distance formula. So if I calculate, if you see that OD passes via origin, likewise AE passes via a comma 0 comma 0. Now if I use the shortest distance formula, so it will be a 0 0 0 b 0 and a b c divided by square root of cross multiplication of the direction cosines, that is these two rows. So it will be square root of bc square plus 0 square plus minus ab square, and if I simplify all this, so it will be equals to abc, absolute value of abc divided by square root of b square c square plus a square b square. Now from the square under root I can pull out b square, so it will be square root of, it will be absolute value of a b c divided by absolute value of b times square root of c square plus a square, and it simplifies to ac divided by square root of c square plus a square. I have removed the absolute value sign because a, b, c are basically the lengths of the parallelepiped, so these will be anyways positive, so we can easily remove the absolute value sign. Likewise you can show that shortest distance between OD and BE will be equals to this one, and shortest distance between OD and AG will be equals to AB divided by square root of a square plus b square. So that's how we calculate, that's all we are supposed to show. So this completes question of basic vector algebra asked in both UPSC, CSE and IFoS service examination. So in the next video we'll see questions related to differentiation of vectors. Thank you for watching, and please do like, share and subscribe the channel.